In this video, we're going to look at the last problem at the bottom of page 593. And this is something that the AP does, is that they kind of are going to give you one problem and then they'll ask you a bunch of calculus. They'll manage to test a bunch of your calculus knowledge with a single function setup. All right, so this time in the last part, we want to find the value of the second derivative of f, evaluated at 2. So once again, instead of thinking about 2 at the moment, I want to take a step back and calculate the second derivative at any value of x. All right, what do I already have on this page that can help me with this? And what do I need to do to that in order to fill out the rest of this line? Well, once again, I've got the first derivative of f listed right here. So how do we get the second derivative from the first derivative? Well, the second derivative is the derivative of the first derivative. That's kind of what second means. So the derivative of 2 times g to the 2x. That might look a little bit strange writing it in this way, but this is really finding the derivative of this is just once again an application of the chain rule. First thing we're doing is we're multiplying this thing by 2. So the derivative of this is just going to be 2 times the derivative of this. So we'll pull this 2 out at first. And what's the derivative of g of 2x? Well, we've got an outside function and an inside function. The outside function is g. The inside function is 2x. So what does the chain rule say the derivative of this is? Well, it's the derivative of the outside function applied to the inside function times the derivative of the inside function. And the derivative of 2x is just 2. And so f double prime of x, clean this up a little bit, is just equal to 4 times g prime of 2x. And once again, I'll throw a star on that. Okay? So now we want to find the value of the second derivative evaluated at 2. So once again, I'm just going to plug 2 in for x. So that's 4 times g prime of 2 times 2, which is 4. All right? And once again, we've got this interesting feature where we've got this graph of g, and we're kind of thinking about g in 3 different ways. We're taking the definite integral involving g, where we're finding areas. In these problems, we were actually calculating values of g, so the value of g at 2. And how should we think about the derivative of g by looking at a graph? What is derivative talking about? Derivative is talking about slope. So what we should do is we should say, what is the slope of this complicated curve when x is equal to 4? What is the slope of the curve at this point? Or, I'll put this in another way, what if this is a trick question and it doesn't make sense to talk about the derivative of the curve at this point? Well, let's talk for sure about where it does and doesn't make sense to talk about a derivative. And what I want to do is I want to go back to our kind of first notion. And imagine we've got a super good magnifying glass that lets us really zoom in on a function. Does the function become a straight line if we zoom in close enough? And if so, what's the slope of that line? That's what the derivative is. All right, so if I was talking about the derivative of this function when x is 3, then yeah, if I zoom in on that, that's going to look like a straight line with a slope of -1. In fact, it looks a lot like a line with a slope of -1 without using a magnifying glass. What if I talked about g prime of 0? Is that something that exists? Yeah, this is part of a circle, but if I zoomed in really close, it would look like a horizontal line because it's right here where it's at the top of the circle. So the derivative at 0 would be 0 because it would look like a horizontal line. What if I talked about the derivative of g at 2? Does it make sense to talk about that? Well, if I zoomed in on this point with a super close magnifying glass, what would it look like? Well, it would kind of look like this. And so we'd have a nearly vertical line there, and then heading off with that slope of -1. So this does not look like a line that I can calculate the slope of. This is a more complicated figure than that. So the derivative does not exist when x is equal to 2 for this function. I wrote y equals g of t, but we all know that a graph has an x and y axis. All right, so money problem. What about 4? Is this something where it makes sense to talk about the derivative? And the answer here is that 4 is an endpoint of this function. So if we zoomed in really close, no matter how close we zoomed in, it would look like this. All right, so we would never have an entire line to calculate the slope of. It would just be a section of the line. So if I talked about g prime of 3.9999999, then yes, that would, if you zoomed in close enough, it would be a line segment with a slope of -1. But g prime at 4 does not exist because that's an endpoint. So to use fancy language, g is not differentiable at 4. So f double prime of 2 does not exist. So not differentiable is just a fancy way of saying that the derivative does not exist. Okay, so that kind of gives you a sense of how we can use the fundamental theorem of calculus to talk about integrals, derivatives, and the second derivatives, all talking about slopes and areas and values of functions. And so you're going to find that those kinds of questions that tie together a whole lot of concepts like this are the kinds of things that we will see on the AP exam. All right, in the next few videos, we'll go ahead and look at the next couple of examples in the worksheet, but it's really going to be the same concepts asked in slightly different ways. So maybe before watching those videos, see if you can make a stab at those problems yourself and see how successful you are at it.